All right. So this time we're gonna talk about do some review of the last session. Okay. There's a repo for that. This one. Yeah. If you can just clone that. Or for you to run npm install and or yarn on it. Yep.
Week 0, right?
Week 1. Week 0 was last week. Sort of orientation. So it's called week 0. Okay. Yeah, gotta run the installation.
It's already installed.
Oh, okay. Yeah. All right. 1 second. Okay. Yeah.
Good.
Okay, so this is a bit of a review of what we talked last week about compose and curry. So I got a bit of an exercise I put together, like really small one, relatively easy, as in about 2 days into, if you use that at work, about 2 days, you got those kind of levels, basically. So the first kind of exercise is you got a data in a structure like this. You have A, B, and B contains, B is an array of string. And you need to compose a function to get the content joined in the B. So this function called with data1 will produce content in the B. So we can do this together, and we try to use point phrase style as much as possible. That means there's no variables. Okay, it's only composed of functions. There is no variables in between, like inputs, outputs. We just compose them instead. So anyone? You can use Ramda functions. Any Ramda functions you can use. Yeah?
So I have to import in the header.
Yeah, just fill in the curly brackets. Yeah.
Cool.
So just, like for this one, if you're not really familiar with this kind of structure and programming, let me just go through what's going on my mind with this kind of a problem.
Yep.
You want to get the join string out of B. That means first need to get into B.
Mm.
And then join the contents once you have B.
Yep.
Yeah. Okay, so you get the object and you go through a sequence of keys. That's called the function called path in Ramda. What it does, well, we can have a look here.
Yeah.
In Ramda documentation, you can search it very easy. The path function takes the path you want to go through first, and then the object second. Now we will touch on why is this order, this parameter this order. But here, basically, you want to do is the other thing is every single function in Ramda is automatically curried. You can call it with the parameter in the bracket or individual brackets set. Yeah. That means if I just a bit of a utility kind of a thing first. If you click the open in repo here, and you will copy and paste the code in documentation into the repo. Just a second for it to load. Maybe the network is slow.
I find it's quite slow around the repo recently.
Right. Okay. We'll just wait for it to be loaded. But what you can do essentially is to call this part first and then call this part second. That means the path function can be called like this. For example, let's name it something else. Something else. Literally, I mean, and something else. Yeah. So that will get you AA as a string, right? Oh, sorry. It's also valid to do. Let me just format it nicely. Bracket here. Bracket here. So every single function is like this. You can break up the parameters and call them individually. That means we haven't. What I mean by point 3 first is you see the input here, the data 1 should not be referenced in this function. You describe a series of computation. There is no intermediate step for you to say this variable blah blah. You just describe your computation. The first step of a computation is path, right? Let's think as in you wanna get into a certain object. I don't know what's the object yet. I want to get to a certain object using this path. Okay, I'm waiting for the object to come. So the first part will be I'm getting to a certain object with this path. The path here will be A and B, right?
Yeah.
Okay, so the second operation I'm doing is because at this point, the highlighted blue part, I'm getting the value for B, which is the array of strings. Now, there's a function called join, which, let's have a look. Given a separator, and you call it with an array, you will join it like this. Right? Given a separator, and the data you want to join from an array
to a string.
Yeah, to a string. That means again, I'm just going very verbose here, right? Join the separator 1, 2 is equivalent to say join that, right? So that's the operation, the highlighted part. That is the operation you're looking at. That's the data part. Yeah, the operation can be composed. Not the data. Data doesn't compose in a sense. Okay. You compose operations. So here, when you're looking at this function, it consists of two parts. First, compose a bottom up, right to left. So if I write like with line breaks, it's bottom up. So the first operation you do is, given whatever object, I will go to A and B as key in order, and then grab that value and then put them together with a space. Yeah. You describe your operation computations instead of let's say I have an object here, I call it like this. I'm not doing that. Right here, you're looking at an array here. So this is basically not the point style, not the point phrase style, like as in point phrase style. Okay. So because we describe and operations or computations, we don't need them. In simple cases, there's a very complex kind of a scenario. You may need them, but we'll look at other ways to deal with them. Yeah. So the second one, this exercise basically is to get you to familiarize with the Ramda library a little bit. I have a function called f1, which is just do a bunch of algebra on A, B, and C numbers. Yeah, and then I have f1p, which flip the first two arguments. Okay. You don't need to compose here, just placeholder. Basically, you need a function to be called, some function to be called on f1. You need to figure out what that function is. You guys want to have a try? That's in the Ramda's documentation. If you can find that.
So flip?
Yeah. So the flip function, let me just put that on the screen. The flip function only flips the first two parameters. It doesn't really matter how long it is. And the function flipped by a flip function is also a query, automatic query function. Okay, so we can do flip here. Let me just import that. Yeah, so that's easy enough. Here is another use case of how to change, on the case of how to change functions parameters around. So same function, but it's queried. Okay.
You don't need to compose for that case.
The one before?
One. Yeah, it's
you
only
don't
one
need
method.
It's also valid to do this.
But it's only one.
Yeah, it's only one. But for in practice, I when I write function, I always do compose first, and then I start to writing function afterwards. Because you don't really know how many functions you need. 50% of the time maybe. Okay, so this function, the inside is the same as the function above, but it's queried. What I want is another function, let's say f2p equal to undefined at the moment. I want to implement it so that the second and third parameter is flipped. Right? Certainly flip cannot. Well, flip can do this, but you need to flip in a very unique way. But here, I want to introduce another thing called the let me just the double underscore. Okay. So in the Ramda documentation, well, we went through this scenario last time, right? The curried form of things. Now Ramda, let's say G takes 3 parameters, then this is actually calling all of them, right? What if I only want to apply the second and third parameter first? Then I need to place a placeholder here. Right. Okay. So that will actually produce another function waiting for the first parameter to come.
Yeah.
Yeah, you get it? So this means the third one has been applied, waiting for the first one and second one to come. Right? So this function. We call 1 later, it will put here. Call 2, it will be put here. Okay. It's available as, I think, double underscore in Ramda. Then here, what do we do here? Let's say we have 3 parameters. We want a third one. Sorry. That means I can just placeholder the first one. Can I?
Like the
If I-
was.
That is, what does this one do? This one means the first one gets
A.
the first one gets what, like, put into the end, right? It will, let's say, if I do this, FP2 will become, you put B and C first in A.
Oh, okay.
Correct?
Oh, because you already covered.
Yeah. But that's not what we want, is it? We want to flip the second and third one. How do we do that? This is just like a demo scenario. Normally, you would be doing this,
Oh, yeah.
right? It's easy enough. What you also can do is to get this.
And then another placeholder.
Sorry. See. Yeah. Does it make sense? Or you can do this.
The third one should be C.
Third one. I want it to be flipped.
Yeah.
The 3, 2, and 2, 3.
Just the return value.
So you keep the first parameter as it is.
Yeah.
And then you put a placeholder and a double underscore to skip your.
Yeah. So now I can just. So this is actually mirroring what you kind of flipping the parameters in real production code. You won't do this, right? I'm just trying to demonstrate that you can, using underscore, to actually reserve, just put like a pot here, right? Later on, someone comes along, it would be, yeah. That's basically what you do. Sometimes you don't use flip because when you do flip, you type 4 characters, right? And you have a set of brackets as well, so 5 characters. And the score is just 2 characters. You want to, for example, find And the find function in Ramda takes a function and then takes, for example, an array of something. And if you want to take the array first, you just do this. A function second, array first, you just do this. Right? So you apply the array first here,
Yeah.
as if, right? And then you're just waiting for the f to come. Yeah? Just put a hole into this argument, and then it will come later.
Okay.
Yeah. But find actually receives the f first, supposedly. Yeah. Okay. This kind of structure, it's deeper here, ABC, array, DE, array. Now I want to do this, append 2 to C, that means doing this, okay? And append 3 to E, do this. I want a function to do that, which I have the result here, right? This function. So how do we do this? It may not be composed. And the thing is, if you haven't read through the documentation, you won't immediately understand what we try to do here. Anyone knows the function to do this?
This is the length. I mean, you can use length to select the C.
Yeah,
pass on C.
that possibly will be two lessons afterwards.
Yeah, that's true.
Path would be good for one, right? When you use path, right, you're gonna apply twice basically to the same object to change it and merge them somehow.
Yeah.
Yeah.
Right. There is a soak path which you can use to do that individually. So into a particular path, given a value of an object, it will replace that, not replace, it will produce a new object with the new value into that path. But that's not what we're after here. What we're after here is evolve. This is the most common function if you're using, if you use Ramda in Redux. Because in your state management, your Redux, right, your state, more often you take an action, type equals to this, and then you want to change a couple of values in your state. They normally are separate into your state, into this kind of structure. Now what you can do is I say evolve, and I name the path individually. It takes a object. You just going through the path to the place you want to change.
Yeah.
Now you reach C, right? You just writing plain object so far, right? And then you put a function here, append 1, and here D E you append 2.
Is it 2 out 3? 2 out 3?
3. Yeah.
Yeah.
Thanks.
That's
Yeah.
good. That's
Right. That will get you what you want here.
nice.
So this is a very common function to use in basic Redux and kind of a state management.
Yeah.
Yeah, I think.
Lodgement reducer.
I think the current code base in the.
Need this one.
They use spread. They have a lot of spread.
Also, Immutable.js has something similar, but a really convoluted way to.
Deep merge.
There's deep merge, but it gets pretty messy when you do multiples.
Yeah.
And you want to do operation. And the one thing I want to be clear here, because this again is point 3 here, because this is the C, the old C value. Old C, right?
Yeah.
People often make a mistake when they want to just assign value, not transform. For example, if I want to change
Replace.
1 to like empty array.
Yeah.
What you need to do here is not empty array. Does not work. It takes a function.
Oh, okay.
So it needs to be always. What does always do? Always do ignores the parameter and it returns whatever you assign here. Right? It's a function. It's just a function returns always return this particular value. It disregard whatever the input is. Yeah. Okay, I haven't imported the things at top, so and evolve. Yeah.
But using so in the current example, what if the object is quite large? For example, you have a really giant, but you just want to update certain, I mean maybe one field. I mean in that scenario, maybe it's better use length or not.
If you want to use just update one field, right?
Yeah.
Let's say only C.
Yeah.
You just do a soak path.
Yeah.
What you do here is you pass the path you want to update, A, B, and C. And let's say you want to update it to, be aware that this is the plain value here. There's no appending you can do. You just assign the value here.
Yeah.
Let's say you want an empty array here, and then the data too. Right.
Oh, okay.
Yeah. So that will assign empty array and
Choose
here.
Oh.
Yeah.
Mm.
Obviously, this way you lost the ability to take the original C and do something about it. In Ramda, I think the only way you can do a transformation based on the old value is using evolve on multiple keys in different level of nesting.
So if two fields, more than one field,
Yeah.
maybe two fields, you have to use an evolve or.
Yeah, two fields. I mean, evolve is the
Evolve.
quite simple one to use. Yeah, it's very good abstraction. Yeah.
So what if I have, for example, I have other fields like A, B, C, D, E, F, G. They're also really deep, for example, really giant JSON.
Yeah.
But if I just want to change A and B, these two fields, how to better write my code just to make it shorter instead of just make the whole giant JSON in my code.
Oh, you mean when the path is really long?
Yeah, for example, if we have AD in this case,
Yeah.
but if we have C, D, E, F, G, which have a lot of
You mean
nested JSON.
Yes. Oh, you don't need to specify those.
Oh, we just
So
use a spread.
yeah,
right?
so I
okay.
understand what you mean. So
Okay.
here, if you have another field F of some value,
Yep.
You don't want to change it.
It's a spread.
it will be kept as is.
Ah.
It's just leave it.
Yeah. It will only change the things you specify
Oh.
until that point you reach the function.
Okay,
Other things you will be preserved.
that's really nice.
Right. Okay.
Mm.
So F will be preserved and touched as is. Yeah. So okay, so I can show a bit of a state management code. What we have.
So if you
Yeah.
add a placeholder into the key, will it just skip that key? For example, if I replace the A with the placeholder, and then you just go to the second B, go through all the objects key, and then go to the second object.
What do you mean?
So for example, I have the object is A, B, C, and the other one is D, B. So if I want to change the second level, the B,
Right.
and then the C,
So you just
but the first level is different.
you want to change like nesting, like
Yeah.
you want to change B, but you also want to change C. Is that what you mean? Like you have something here, and you want to change C and kept D.
No.
No,
I mean,
like
so
probably this is ABC,
Yeah.
and you have another D and B.
yeah.
You want to
D-
change both B, is it?
Yeah, something like that.
You want to change B as well.
Yeah.
You just do another function here. This function will take B as input, and
So
you can't. It can't.
So
Yeah.
if these two, so for example, so this one is also BC.
You can copy paste
sorry.
BC
And
from
Yeah.
A. Yeah.
Yeah. And can I just use the placeholder? So if the object is the same, this object is like this one, can
Right.
I just use placeholder and then you?
No, you
Change
can't
it
use
over.
place. No, can't use placeholder. Yeah. So it needs to write. And I would. And then you're dealing with if you have the same structure, right? And you tag them with A and D basically, right? So
Yeah.
BC is same structure.
Yeah.
You want to tag them with A and D. Then you're looking at a structure very similar to list. You possibly want to deal with it using a list kind of a function to anything deal with array. Yeah.
Object of list.
Yeah. So this is basically objects. If you're looking at objects with patterns, then maybe something else is suitable. For example, I'll just mention a bit. Map object index. This function. What it does, let me just increase the. It loops through the object as if it's an array.
Okay.
Yeah, but on the first level key. Yeah. So that means you can do evolve on mapping, right? Then will be changed. Yeah. Let me show you a bit another code. See if I can get them. This is a reducer for whatever purpose. Okay. It's your usual kind of initial values, right? Type. That's the action, right? And you match against it, and you do evolve basically. And evolve takes 2 parameters, right? So this after line 78, it's still a function here, correct? That means this bracket will produce a function and put state in the end. So this huge block here, it just match against this type, produce a function. Match against this type, produce a function. If doesn't match anything, it's just identity function, right? What goes in, what goes out. Yeah. So here you just state and just put in the end. So you basically produce functions in between. Well, save your typing, state brackets basically. That's one. Here's the last exercise. So this one. Yeah.
It's just the parameter like passing.
This one's a bit funny. I have this function called stats. What it does is it takes 2 parameters, 2 string value which contains numbers in them, and it tells you the total characters of those 2. Total characters of, it should be 4 of those 2 strings, and then it gives you 2 other keys. One is to say the first argument is a positive or negative. The same thing for the second argument. So this is done. There's another very useful function called. Anyone knows how to do this? It's basically taking parameters, constructing this object. What you do is actually this function apply spec.
Oh yeah, that's really.
Now the intuition behind this is, let's focus on the data first. Just ignore the keys, all the keys in this object. The 4, the true, and the false can be obtained by very simple functions, right?
Yeah.
Okay. So what's left is actually just constructing this structure. Okay. Apply spec gives you that. What it does is every single function into a structure has a key value match. So this add function is matched to sum. This multiply function is matched to this mul nested in this nested key. And when apply parameters, those parameters has been passed to them within the structure. For this example, it will be let's just copy the structure here. Okay. Got this brackets wrong. Yeah. So the 4 is actually the average, right? Remember those functions you put into these places takes the same parameter of the final function. Understand? So the 10 and -2 has been passed to individual one of them repeatedly.
Oh, okay.
Okay, so here it will receive 10 and -2. Okay, that means I need to do this. You can just, it's an array. You can just calculate the average on that. You know how to write the function, right? Average, and then here it will just the first one and the second one you ignore. Basically, you just right like this. Yeah, something like this. So every single function you put here will receive the same parameters when you pass to here, which is when you call it, which is the 10 -2. Yeah, well, obviously you need to pass into here.
One question: do you have a comma is underscore? Is that a underscore?
Yes, underscore.
That is for.
There's no
Placeholder.
special purpose. That's just a character as a parent name. In functional programming, we usually in Haskell, we use underscore as in I don't care about this thing.
Okay.
Right? You can name it B, C, D, but you give it a meaning.
Yeah.
Right.
Okay.
By writing underscore, you basically say it doesn't have any meaning.
So what's the difference between 8 and the placeholder?
This is not a placeholder. Double underscore is a Ramda placeholder. This is just an underscore. There's no difference than A, B, C. There's no difference. Yeah.
So
Just no value.
Just the underscore will be -2.
Right now.
Yeah, right now it will be -2, right?
Okay,
Yeah.
I see.
Okay, it's
So
just a parameter. It's a legal
meaning-
character.
the second parameter, like.
Yes.
Okay.
Yes. But obviously you can't do this.
Because you don't
It's
have.
only two.
You have naming
Undefined.
convention. Yeah.
Okay.
Most of the time one is good enough. Some people when they have multiple write like this, but again it gives some meaning to it. If you have multiple things you ignore, you just write point first style and extract the parameters. There's a bunch of random function for you to extract parameters. So
Also, can you just ignore the A B because
I can do that.
That's point free, right? So you.
So for this one, I can do. Is it larger than 0? There's a function. Larger than.
That you need to compare
things like that.
A or B or either one, right? So you put in double underscore to ignore the first character.
I think it writes like this. Then A, I think it get. It's pretty weird the order of the parameter. I can't remember. It's either this or this. I just can't remember. The larger than function, which one takes first? I can't remember.
Okay, so you don't need to return in the apply spec because previously there's you return something, right? It's a function. Actually, LT return. Yes.
Yeah, it's a function itself. Yeah.
Okay.
It will later on be called by A and B. Strictly speaking, it's not quite correct in a sense because this function only takes one parameter after 0.
Also, for the first one, we can just say we can call length something to check the
length of the
length of
characters.
So apply length.
Apply means apply, but you need to add the two values together, right?
Yes.
Okay.
Maybe.
I want to gather all the parameters of a function, basically. Right. I'm called with A and B. Right?
Yeah.
I want this A and B becomes
One
array,
string. Array.
Yeah.
Okay.
and then I can
Okay.
concat them and count the length.
Okay.
So it's not quite straightforward.
Yeah.
But yeah.
Mm.
So
Mm.
I'll leave that to you guys, I guess. Next time. Just to illustrate my point, this function is also a very interesting function when you want to all the parameter to be fit into different functions and produce a structure. It's like you want to calculate the deviation of array of number and also the average of them. Right. So, yeah, let's take a break. I'll talk about other things after this.